hope you are doing good, guys. Let's just remind each other about a triangle, or the properties of a triangle that we didn't talk about maybe in other grades, even though we talked about, but we didn't actually dwell much on them. So we have this side, as well as the bottom side. So in other words, a triangle has three sides. We're talking about interior angles, but now we're going to talk about the sides. We have AB, BC, and AC. Please do not forget to subscribe to the channel. So what's important here is that a triangle has three sides. So that is very, very important. It's something that you must actually know when it comes to this topic. We're dealing with sides here. Very, very important. So please like the video, guys. I will really appreciate that. Okay, this is proportionality theorem. A line drawn parallel to one side of a triangle. Now remember, a triangle has three sides, so this line will be drawn parallel to one side of a triangle. Then it divides the other two sides in proportion or proportionally. So a line drawn parallel to one side of a triangle divide the other two sides proportionally. So let me just show you this in a triangle. Okay, so here we have, let's say this is A, or triangle ABC. Then there's a line that is drawn here. Then this line is parallel to one side of a triangle. Then we have XY. So XY here is a line that is drawn parallel. So XY is drawn parallel to one side of a triangle, which is BC. Then when that happens, what happens to the other two sides? They are divided proportionally. These two sides are divided proportionally only if XY is parallel to BC. So what does that mean? It means that if XY is parallel to BC, it means AX over BX is equal to AY over AC. Only if XY is parallel to BX, then AX over BX will be equal to AY over YC. Then you don't just keep quiet, because this is Euclidean geometry. Whatever that you write, you provide a reason. So what's the reason? We say proportionality theorem, you can say prop theorem. Then this is not enough. You show us the lines that are parallel, which is XY being parallel to BC. Then after this, that is when you can continue to solve whatever they want you to solve. But the most important thing, or what you must know, look for what? For proportionality theorem. How do you look for it in a triangle? By checking if there is a line that is parallel to one side of a triangle. Then if there is, it means that it also divides the other two sides in proportion. I hope we understand each other there. So that's the most important thing. All right, I hope you understood that part. Now this is a X and Y. It's a line that is parallel to BC here. So AX over AB, you can still use it in that way. AX over AB equal to AY over AC, only if XY and BC are parallel. You can still use it in this way. Then you write the reason, proportionality theorem, then you show us the lines that are parallel to each other. This will never be written if XY and BC are not parallel. I hope you are following. So this is a very, very important thing for you guys to mind or for you guys to note. Okay, so I'll explain it again so that we understand it. Then we try to do questions based on proportionality theorem and continue. Okay, so this is our triangle having three sides, as you can see. Now we have, let's just name it, we have triangle A, B and C. Then there's a line that is drawn here, let's call it XY. Then this line is parallel to BC. Then it divides the other two sides in proportion. So if XY is parallel to one side of a triangle, which is BC, then what happens? It divides the other two sides in proportion, AB and AC. I hope that makes sense. Meaning that if XY is parallel to BC, then what we know is that, or what you must know is that if XY, I repeat this, if XY is parallel to BC, what you must know is that AX over BX, AX here over BX here, this is BX or XB, will be equal to AY over YC. Then you write it YC. Then you don't just keep quiet here. What made you to write this? It's because there's a line that is drawn parallel to one side of a triangle. So you write prop theorem, then you don't just keep quiet. You show us the lines that are parallel to each other, which is XY parallel to BC. So this is very, very important. Then you can continue to solve whatever they want you to solve. So the most important thing is for you to find proportionality theorem. Then that's it. You can continue with whatever that you want to do. I'm not sure if you guys are understanding this. So that's the most important thing. I hope now it makes sense to you. So if it does, please like the video. Let's say we have 5 here. X let's say this is A, alphabet A, and what else? Okay, let's just use other numbers for argument's sake. Let's say the length of AX is Y and the length of BX is 2, then the length of AY is 6 and the length of YC is 3. Find what? Not X, find Y. So this is what they want us to find, the length of AX. Now we've written what the proportionality theorem here, so there's no need for us to write it again. So by knowing that, we can do what? We can solve for Y, right? What is the value of AX? The value of AX is Y, and the value of BX here, we're going to substitute that to where there's BX equal to, what is the value of AY? It's 6. Then the value of YC is 3. Therefore y over 2 equals 2. Then you cross multiply, then you have what? 4 as the value of y. You write 4 units. So this is the length of AX, as you can see. So here the length of AX, or the value of y, that's 4. So AX over AB must be equal to AY over YC. So let's prove that. 4 over 2 equals what? Equals 2. And 6 over 3 must be equal to 2. So you see that whatever that we are doing is correct only if xy and bc are in proportion. Or you can use this one, ax over ab. Ax is 4. What is ab? You add 4 and 2, you're going to have what? 6. Then this is equal to ay over ac, 6 over 9. Then you can use your calculator to check if this is correct, meaning 4 over 6 must be equal to 6 over 3. 6 over 9, which is 2 over 3, 2 over 3. I hope it makes sense. So it's very, very important. You can use both the ways, but you cannot use them if you didn't check if proportionality theorem does exist in your triangle. Alright, let's try to do something here, but I hope you're understanding, guys. Alright, now let's say we have the saying that in triangle PQR, the lengths of PS, SQ, and TR are 3, 9, 2, and P equals 6 units. So PS equals 3, and the length of SQ is 9, then the length of PT is 2, and the length of the entire TR, as you can see, TR is equal to 6 units. So here TR combines CB and BR, then the entire length is TR. Okay, let me just fix this line here and try to make it a straight line. Okay, so the length of TR we're having 6, right? Then they're saying that give a reason why ST is parallel to QR. Where's ST? Let's see, where this is ST. They want us to prove that, or to show that SC equals QR. It means that PS and SQ must be equal to PT over TR. So that's what the converse, or that's the reverse of of proportionality theorem. Therefore, PS over SC must not be equal to PT over TR. Why? Because you are yet to prove that. So if you use it this way, it will be incorrect. Why? Because it's not that ST is parallel to QR. We must show it, meaning that you must find PS over SQ. Then if PS over SQ equals PT over TR, it means SC is really parallel to QR. I hope you understand that. So that's very, very important. So what is it that you're going to do now? PS it's 3, then SQ we know that it's 9. So this is 1 over 3. So if we solve for PT over TR and it gives us 1 over 3, it means that SC and QR are parallel. Then PT over TR, we know that PT is 2 and PR is 6, and this is 1 over 3. And if you can check or compare these answers, we have 1 over 3 and we do have 1 over 3. It means that SC is parallel to QR. But the reason you say therefore SC is parallel to QR, they wanted us to show that, then what's the reason? You don't write proportionality theorem, but it is the reverse, or you say converse proportionality, or converse of proportionality, or prop theorem. So you are done. I hope you understood this. So PS over SQ, we proved that it is 1 over 3, and PT over CR is 1 over 3. Then we can actually conclude saying that SC is parallel to QR. Then you don't just write prop theorem, is the converse of proportionality theorem. Okay. if AB is parallel to QP, this is AB over here, and this is PQ, then PR and QR will be divided proportionally or in proportion. So since you can see that we are having RA over AQ, it means that BP over, BP over, okay, it's BR over BP. Okay. Let's actually talk about this. RA is to AQ. This is a ratio, and the ratio can be written in a form of a fraction, meaning RA over AQ is one and the same thing as RA into, RA is to AQ, meaning 1 is 1 and 3 there. That ratio of 1 and 3 can be written as 1 over 3. And you can see that AQ is 3. We can say it's 3K because that is the ratio, not just the length. Then AR, it's 1. You can say it's 1K because that's not the actual length of AQ and AR. Those are just ratios. Then what you must know is that since AR, A, B, and PQ, they divide the two sides in proportion, we can say BR is 1B, and PB, you can say it's 3B, or you can use any alphabet that you want. These are not the actual lengths, but these are ratios. Then we are required to determine the value of BT or TB. Okay, now this is what we have. Let's say we have PR, here we have B, and here we have T. Is that side PR that we are having on the triangle? So I'm just showing you here so you can easily see it. We do have the value of TR as 6, and it is 6 units. This is the actual unit. This is the actual length, not just the ratios. And what do we have? We have 1B here as BR, and we do not have anything. We must solve for that TB. And what else? Do we have the length of PT? Yes, we do have, which is 2. And the length of BP, this 3B, that's the ratio. And what else? We do have the length of PT, that's 2, yes. And if you can look at this, we do have TR. Then if we can add TR and PT, it will give us PR, meaning PR is 2 plus 6. We're going to have that 8 units. That's the length of PR. I'm not sure if you understood this. So 2 plus 6 here is going to give us what? PR, which is 8 units. And this is the actual length, not the ratio. Meaning those that are up there, those are actual lengths, and PT is also an actual length, except those that are having alphabets attached to them. Those are ratios. Okay, we do have PB, and we do have what? BR as ratios. Now let's see, we can have B plus BR, that will be equal to PR as units, meaning we'll have 4B. Then up there we have 8 units as PR, but PR as units, as ratios, we have 4B. Then PR, we do have 8, meaning that PR, the actual length, is equal to PR, what? The ratios. I'm not sure if you understand that. So we divide both sides by 4 so that you can find the value of B. Now the value of B is 2 units. I'm not sure if you understand that. So the value of B is 2 units. So if you didn't understand this, make sure that you do what? You rewind the video. Okay, meaning where there's B, you can substitute that value of 2. Let me just substitute it here. This is BR. Now BR equals 1B. 1 into 2, the value of B, we have 2, right? Meaning the value of BR is 2. We are having 2 here. Then for us to find TR, it means that we're going to say 6 plus that 2B, which is BR, it's going to give us what? 4 as the value of TB. Therefore TR equals what? BR plus BT. We do have the value of TR, it's 6. We do have the value of BR, now it's 2 plus BT. So what is value of BT or TB? Equals what? 4 units. You have solved now for TB. But it needs you to understand the proportionality theorem, and when you have ratios, you must use alphabets. Those are not actual lengths.